My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Go Cloud Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the Go Cloud team.
Welcome, everyone. Today, we are here to discuss multi-cloud architecture and hybrid multi-cloud architecture. And we will talk why 98% of organizations have a multi-cloud architecture. So if you want a great cloud architect career, enterprise architect career, solutions architect career, or any career for that matter, you're going to need to know multi-cloud. And that's what we're going to be talking about it today. So welcome, everyone. With me, I have Mark Milovanovic, who is a CCIE network architect, and he's great at what he does. I also have Alonzo, who happens to be our chief marketing officer, but he's a great enterprise architect as well, and he knows a lot about business planning and business continuity planning. So we're going to have this show for you today. Before we begin, I want to tell you about some free things we have to assist you in your career. First thing I want to tell you about is tomorrow, we're going to have our How to Get Your First Architect Job. It'll be live and free on Zoom. We'll go over the role. We will cover every skill you need. And you can ask us questions. And guess what? We'll answer them. And we can interview you if you desire. And we'll give you live on Zoom feedback to help guide you through your career. And that's tomorrow. And it's free. I also wanted to tell you that when we're done this session in about an hour, We're going to come back and we're going to do any kind of technology career questions right after this. So if you want to know how to become an architect or how to go from engineer to architect or how to get your first cloud engineer job, network engineer job, network architect job, AI architect job, enterprise architect, security architect, we can cover them for you. And we want to do anything we can to help you. And that's also all free. And in the description of this video, we've got tremendous amount of guides on winning the interview, guides on how to be a cloud architect or an AI architect or an enterprise architect, and they're all free in the video today. So we're going to talk about multi-cloud architecture and hybrid multi-cloud architecture. But I have a question for all of you. I really want to ask you this question, and please give me your answer in the chat box. How many of you only shop at one store for everything? For your clothes, for your cars, for your groceries? Tell me in the chat box how many of you have limited yourself to a single store, one store. And actually, while you're at it, if you had to limit yourself to a single store, maybe tell me which one you'd pick. I'll tell you what my pick would be, and I'll tell you why. But at least for me, I don't shop at a single store. And while we wait to hear that, Alonzo, do you shop at the same store for everything?
No. No. And even if there was a one-stop shop, it would always be from a singular point of view. So would it be, I want to know what other people are thinking about how they design things, where the materials come from, what their innovations are, and so forth. And if I can only get that from one place with only one thought process, it'd be pretty boring.
Yeah. So, I mean, how about you, Mark? Do you only shop at one store?
That's a little bit of a loaded question, to say the least. The first thing that popped in my mind when you asked it, I says, like, why would I lock myself into one particular vendor? I guess that's the IT just coming out of me. But no, it wouldn't make sense, right? From many perspectives. A simple one would be that I've never gone to a single store and been able to find everything that I required that day. So that requires me to go out, look for an alternative where I can actually pick up everything that I need to. So from a pragmatic perspective, that's why you should always go to multiple stores, because why limit yourself? Why restrict yourself?
Exactly. And I'll tell you, if I had to pick one store, it would probably be Walmart, because I could at least get pharmacy things there. I could get food there. I could get clothes there. I could get auto parts there, some sporting goods stuff. So if I had to limit myself, it would just be Walmart. But here's the thing. Sadly, about 20% of the time I have to wear a suit. So, kind of keep it in the back of your mind that I can't get at Walmart. And yes, like the Tin Man said, you can't get your TV at Publix or your clothes at Best Buy. That's exactly the case. So Tin Man, I completely agree with you. And Seaflow, it's not just a single store for you. I didn't think it could be. And for that reason.
Well, one thing that I can say is that being in Texas, if everyone knows about Buc-ee's, that would be the only place anyone would ever shop.
Okay, and I got it. So it's impossible. You get your meat from one store and your other things from other stores. Exactly, and that's the real reality. You might have to get some of your clothes at Nordstrom or TJ Maxx or Marshalls. I don't care. And you may be like me and love Jamaican food and have to go to the Jamaican supermarket for your Jamaican spices. And then I go to the Greek supermarket to get my Greek things, like the special cheese that we would eat in Greece, the local kind, my olives, my olive oil. And then I go to another store to buy my work clothes, and I go to another store. So the point is we generally can't get all our services met from a single organization. And the reality is no company can get all their tech needs made from a single organization. So one of the reasons people don't go multi-cloud is the same reason you don't go shop in a single store. It's not feasible or pragmatic for you to ever get the best of everything from a single store. Could you get away with it at Walmart and get good enough stuff? Possibly. But do you want to go on a wedding in a t-shirt you bought at a Walmart? Probably not. If you have to give a presentation to the board, can you wear something you bought at Walmart? Probably not. If you need a 64-core workstation like I have with a 0.5 terabyte of RAM, can you buy that at Walmart? No, but I need it for some of the 8K video I do and all the monitors I drive. I can't do it. And when we go to a single provider, it's like we're getting that. I had a martial arts instructor many years ago compare me to two knives. Then I'm going to turn it over to you guys with some questions. And I had a beautiful Swiss Army knife in my pocket. and I was trying to learn Filipino martial arts. And Filipino martial arts has a lot of sticks, a lot of knives. It's just like Salon. It's a great art. And I had my Swiss Army knife, which had a little corkscrew in there and had a little screwdriver in there and it had mini scissors and a nail clipper in there. And to keep it in perspective, he said, "You're not going to train with this, right?" And then he pulled out a knife, and it was like the Crocodile Dundee movie. That's not a and this thing was so long, and it fit in your hand a certain way. And he says, "This is what you need." He says, "We will train with a plastic version of this today, but for Filipino martial arts, you can have this curved blade or you can have this. But sorry, you got to send that Swiss Army knife and use it as a tool when you need it." And when we look at the cloud, there are some things that they do which are the best. And then we get into security and go, well, there's other vendors. And then we need some networking. And it's like, well, we can't get it from here. Now we need some really high-end database. And the cloud provider stuff is good, but maybe there's better out there. Now we've got to go multi-cloud. Well, can't use AKS, EKS, any of this stuff, but I can use OpenShift from IBM. So kind of think about it in the back of your mind. But neither of you guys could go to a single store, right?
No. Not in any way, shape, or form. And let's make it a little more complex. What if I need something my wife needs or my children needs? Some of the stores that I frequent, if my son needs after his chores, I'll give him a video game. It's not going to be, at the tool hardware store or anything else. So I need to find the right resource for the right solution, and being able to understand what my options are and how I can optimize my purchases, much like a lot of the decisions that we make as enterprise architects go hand in hand.
Okay. So now, Mark, you've designed high availability networks for many years. When we design a network, everyone that's out there, in case you're new to networking, we have to buy our connectivity from a single company or from a company. I mean, unless you want to dig fiber under the ground to say New York to San Francisco, and literally you're going to get all the permits and you're going to dig under the ground and you're going to run your fiber, we have to buy it from a service provider. Mark, is there ever a time where you worked with a bank or an internet service provider, a business where technology mattered, and they only dealt with, say, just AT&T or just Verizon?
Yeah, unfortunately, I ran into a situation for one of our largest customers a few years ago. They're global international company that deal predominantly with shipping routes and bringing in content and things like that, resources. And for example, what they ended up doing is, again, you don't know this on the backside because you're not always the only person designing these aspects of this, and the customer was involved in an SD-WAN design with us. This is the part where I was in. Little that we know that is we did end up having them lease circuits or services from AT&T and Verizon, thinking, hey, we did well, because if Verizon went down, we still had the other service or circuit available. That's the whole idea about high availability, right? That you always have something else, available to you when something else goes down. Well, little did we know that on the back end, the circuit actually terminated through AT&T's network. So even though it was resold through Verizon, the actual circuitry was still AT&T. So if AT&T went down, so went the Verizon circuit down.
Right.
So in that sense, it caused issues. So a redesign was necessary to actually make sure, now this is from a physical connectivity perspective, right? To be able to actually differentiate on which physical infrastructure the actual circuit runs on. Because otherwise, if you're running on the same physical infrastructure, you get the impression that you have high availability, that you have redundancy, and that you have resilience, which you don't. And we noticed that when everything went down and they were stuck on LTE. And for anyone that's ever been stuck on LTE, it's great in a pinch. But if you're running a multi-million-dollar company, it ain't that great. Let's put it that way. Yeah. So from that perspective, there's so much that goes into making sure that you research these physical infrastructures to make sure that you have a backup, which is going to be that redundancy, so that you can have the service available when you need them. I always like to think of it, I give you a little example. This actually happened. So this was a few weeks ago where my wife was feeling like Chinese food. And she goes like, I'm going to go to my favorite spot. I'm like, okay, go ahead. Next thing you know, a few minutes later, she texts me and goes like, can you believe they're closed? And I said, well, what about the one down the other road? She goes like, that's a good idea. Let me go there. That was actually a case of high availability. We had one store being closed, but having the other one open. So now I had an alternative. Now, did she have to make a minor detour? Yes, but that's part of the high availability design. That's part of having resilience, right? To be able to divert traffic around the actual failure that has occurred. In this case, closure of a store. But we do the same things with networks. We do the same things with cloud service providers, because what do we know about cloud service providers? They still have an infrastructure, and that infrastructure is called the data center. A data center that has this infrastructure virtualized. So we still have to expect that that network paths, infrastructures, they will fail. We don't get around it. They will fail. As a matter of fact, I was looking up some statistics a little bit ago. Outages just alone this year for cloud service providers has actually gone up. So it used to be like almost like an 85-15 split between service providers and cloud service providers. So that was a differentiation between failures. Now it's closer to a 75-25. So we see that it's gone up about 10% just alone this year. So it's a norm that we can expect things to fail. And that's not even going into details in regards to, are we talking failures for physical paths, physical equipment? Are we talking about workloads? Are we talking about just networking paths that are not properly protected? So there's those, failure itself can take so many different shapes and forms that it's going to fail. We have no way around it. And because of that, we have to be aware of it, that multi-cloud is really not an option anymore. It's a necessity at this point. If you're going to choose to go out there, do multi-cloud.
And let's talk a little bit. I want to summarize what you described. So when I learned early on as a network architect is not only can you not use just AT&T for your links, but you'd have to use, say, an AT&T and a Verizon or an AT&T and a CenturyLink. But we used to actually get maps from the service providers themselves, and we would look under the ground and we'd see where the cabling was coming in. So if I knew AT&T was coming in on this side of the building and Verizon was coming in on the opposite side of the building, life was good. But sometimes there's something called the conduit under the ground where they run the cables inside of that conduit, where AT&T and Verizon are in the same conduit. Now, to be fair, if AT&T has a network outage, Verizon would still be up. But you get Billy Bob in a backhoe, and he's drilling that backhoe, and he digs into the ground, and then he chops the cable, and then you lose both. So we had to look, and I am not joking, we had to look under the ground at the fiber map. So the key is, it's not when the technology fails. It's not if, it's a matter of when. And it's what happens when it does. So assuming the technology will fail, because I promise you, it will. And let's say you've got a hospital, or you've got a bank. In a hospital, the systems go down, people die. I don't think that's acceptable. In a bank, the systems go down for an hour, and millions of dollars are lost, enough to cause people to be laid off. And I don't want to see anybody get laid off because the business had a massive financial loss because their systems were down, and the AY went haywire when it had limited things. And I've seen it. I've seen AI and banking systems about 15 years ago that lost about $1 billion in a matter of 15 minutes. They had a tech glitch, and they didn't even have access to the network to fix it. So these things can get pretty big, pretty fast. And then we'll get into the tech itself. But I have a question for Alonzo.
Sure.
Alonzo's got an MBA. He knows a lot about business. He's got that business architect, enterprise architect nailed down. He comes from a family of strategy consultants, which are business architects. So, Alonzo, you know a lot about investing. Would you ever buy a single stock portfolio and just own one stock and then for the future, or would you diversify your portfolio?
I wouldn't do that any more than build a building with one exit and coat the whole entrance in gasoline and just hope I find an entrance somewhere else. That would not be a viable solution. Now, let's consider some things here. So everyone, and it goes to the analogy, you there's no way that you're going to be able to get some unicorn investment where it's going to get 1,000% ROI in 24 hours, and you're just going to ride it out like you're in some casino in Las Vegas in some sort of movie. That's not realistic. You have to understand that the market can be volatile, much like life. And you have to have some contingency plans. You have to have an understanding of, number one, we have to have business continuity no matter what. And that requires a plan B. And maybe even some instances, depending on the necessities of a business case, a plan C, maybe a D. We need redundancy in everything that we do. So much like a well-built home, well-built building, you're going to have emergency exits, much like you have the main entrance. We need that coverage, and continuing to do that will help all businesses maintain their ability to be operational.
Yeah, absolutely. So now let's start talking about some of the main business reasons, and then we're going to get into the tech. So recently, and Google's great. I mean, we're going to talk about companies that are the best of the best. Recently, Google deleted a $240 billion hedge fund from their cloud. Think about that. Now, AWS has had plenty of outages, lots of them. Is AWS great at what they do? They're incredible about what they do. They're incredible. But everything breaks. And when you get to crazy scale, things break a lot more frequently because there's too many things to go wrong. Systems are pushed to 100% of their max. And even the protocols that are designed to connect this stuff aren't even designed for that. So when you put anything at scale, it's going to break. So you're going to expect more outages in a cloud provider that's well run than you want in an organization. So Mark, in 60 seconds or less of a response, let's say I've got a network and I've got redundant paths in all my things and I have my routing protocols. Can I do things like QoS and traffic prioritization on my NetApp and plan my backup connectivity where it's going to go?
Yes, you can. But if you're going to go across a wide area network, you have to make sure that whatever wide area connection you actually have does support the passing along of the QoS tags, right? Otherwise, you can't do it. So internally, though, if you have your on-premise data center, let's say a private type of cloud, then of course these things are going to be a lot simpler. So if you run a hybrid, kind of cloud, you have the backup of your private, and then of course using a public entity, maybe Amazon, Microsoft, Google, etc. But definitely is a possibility.
So Mark, let's say I have a worm or something that's going to hit my network and push it to 100% throughput. Is there a way that I can still guarantee that my mission critical traffic gets through and the worm traffic is deprioritized?
Yes, generally speaking, what you would do anyway, for your low latency type of applications, think voice, video, you're going to have a low priority queue set up anyway for that traffic to be there. You're going to be setting up bandwidth reservations. That's going to be very important. I've seen, and this is not a worm, but this is a real life example where the customer didn't actually put a limitation or restriction on Windows bandwidth updates within the actual system itself. They didn't do that. And we noticed that it was saturating both circuits and then eventually kicking on the LT backup circuit because the other circuits went down from overutilization of their time. So from that perspective, even with a legitimate application, or even more when you have malware, ransomware, anything that can actually eat up unnecessary your links, you want to restrict and possibly shape traffic according to the needs and always prioritize your mission critical applications. So definitely do bandwidth restrictions on most applications, and that way you can never run out. And then, of course, routing protocols do it by default, but when you have to do it manually with applications themselves, you want to.
Would you say that increases security, Mark?
Definitely. Because if you can slow down a worm or anything more than enough, it gives you enough time to actually figure out how you can stop it. I like to liken it to a door, right? If somebody is determined to get into your house, but you have 50 locks in your door, it's metal plated, it's steel, what you're basically doing is you're buying yourself time. Time either to escape or time for help to arrive. And the same thing happens here, right? In a data center in particular, let's say you're running something like a cloud topology where you're running spine leaf, basically just simple 2 hops. What you can do is, since you're generally going to have fixed form factor switches, if you find that something is wrong with this particular switch or some type of server is being infected, you can actually just switch out that server. As simple as that. And just have a straight up running configuration from the very beginning, take out whatever was causing it out of production environment, and then you can still at your leisure take a look at it. So there's various ways of doing it. QoS, of course, is, let me put it this way, is probably the most pragmatic and the most, what's the word I'm looking for? Proactive measure of actually stopping that type of saturation on your links.
Now, can you go to AWS's switches and routers and enable quality of service on their network?
Unfortunately, we have this wonderful thing, which is a problem in the cloud, but beautiful in our networks. We call it abstraction. Basically, we're hiding the complexity of the infrastructure in the cloud. So we actually don't have view nor the ability to change that type of implementation specifics. Right. So we would have to potentially Runtime a software-defined networking solution that allows us to actually peer into how our workloads run, and then potentially limit and apply QoS, shaping, policing, things like
if
that.
their network goes down because they get hit with a worm, then our SDN, our software-defined WAN, goes away because we lost the IP network.
Correct. I mean, from our perspective, there's things we can do. If something happens to their physical infrastructure, then game over, right? That's why you do need that to diverse. It's as simple as that. Just like anyone does any type of investments, they might be in the stock market, trading stocks there. They might do futures. They might go into Forex, doing global currencies. So you do have to diverse because, as we mentioned, failures happen. And this is something very important for everybody listening. When we talk failure, we're not talking about necessarily system-wide or infrastructure failure. If your application can't be delivering the packets, if it's not accessible, that is considered a failure.
Yes.
So even from that perspective, we need to keep in mind on how to build in availability, resilience, as well as redundancy. The cloud service providers are actually very good at redundancy and availability. But again, the more infrastructure you add, the more state changes in your network or into your infrastructure, which means there's changes happening. These changes can be mitigated to a certain degree, but they can't be completely avoided. So failure is inevitable. So no matter what, it's going to be there.
And not only is the failure inevitable, but the cloud providers can't take the same protections we could in our data center because they don't know what their customers' traffic patterns are going to be.
Right.
Now, if we also look at a couple of things, and we'll talk about how to make this happen, who's a bigger target? If you're a hacker or a state government or an organization, let me tell you, who's a bigger target? MyCatCindy.com's website or Microsoft or Google or AWS? You hack into MyCatCindy's website and you're going to see her playing with her new favorite toys, these little bonker Pops things. She chases me around the house for them. She had 7 of these lollipops yesterday. I think it's almost an addiction to my cat, but we're not going to worry about that for right now. She had a trauma and I'm trying to make her happy. But the point is, and I forget where I was actually headed.
Let me put it this way, Mike. I've met Cindy. And the only thing that Cindy is in danger of is being loved way too darn much. Let me put it that way. So from that perspective, the only thing that Cindy is going to have to worry about is all those admirers. So I still pick one of the cloud service providers to be more of a larger target in wanting people to take it down. That's just a reality, right? I will probably put it this way. If somebody just wants to have a thrill, we call them thrill attacks anyway, just somebody wants to have kicks and take down part of Amazon, right? That doesn't even have to be their entire infrastructure. What if they just hammer their content delivery network and for some reason that content delivery network can't handle the distributed denial of service attack? Let's just say for example, right? So what do we do then? That's a partial outage right there.
Yeah.
But at least in that region, right? Globally, okay, that will be a little far-fetched. But at least regionally speaking, if it's a West Coast, East Coast, and then depending on what kind of city, I know Amazon doesn't necessarily give us all those details on where all the data centers exactly at, but it can happen. We got to be aware of that. That's a potential.
And the point is, it's a high value target. It's a target that if you attack Microsoft Cosmos, and it's been hacked, you get access to thousands of their customers versus a single customer from iCatCindy.com. So these are kind of things to think about. These are the business rationales behind it. Let's also talk about, we're going to get into cost, and then we'll give you some guidance towards the end of this of things that you can do to be multi-cloud and how to make it very simple, because multi-cloud is nothing. I mean, people think it's terrifying, but I've been dealing with these multi-data centers all over the world for about 26 years now. I hate to say it because it's starting to make me feel like I've been in this field for a long time, but I've got lots of experience and learned a lot along the way. But if we talk about cost, if I've got a machine if I have an AI system, JP Morgan Chase, I saw Jamie Dimon on CNBC today say he has 2,000 AI people working for him. So, I mean, think about 2,000 people. And and sometimes it makes sense to go to the cloud for speed of the market, and sometimes it makes sense to run things in the data center. It's approximately $35,000 to buy an NVIDIA H100. $35,000 to buy. If we were to use that 24 hours per day, 7 days a week on AWS, you're dealing with about $45,000 a year. Now, if you can keep that card for 4 years, do you pay $180,000 to AWS, or do you pay $35,000 to buy it? But it's not just that, because that's still small numbers. But I think Elon Musk bought about 80,000 of these cards for Tesla, and that's just one company. So think about paying 3 to 4 times more to rent the infrastructure in the cloud, where it won't perform as well because you've got a latency distance to the cloud. It's outside of your control. Why? And then we need storage, right? And the storage is far faster and far cheaper in the data center. So I can get about a 19 million IOPS RAID card for my server. And yeah, maybe I spend $300,000. But you try and get 19 million IOPS at that kind of capacity on the cloud, and you're paying hundreds of thousands of dollars or $1 million every single month, not one time. And you really can't do it unless because the fastest at AWS IO2, and it's good, it's really good for block storage, is 250,000 IOPS. 19, that's 80 times faster effectively. So you'd have to have 80 of AWS's fastest EBS volumes in a RAID 0. And of course, now that would be too risky. So now you're going to need another 80 volumes to make it RAID 10 versus the one thing you get in the data center. So some things just don't work. But cost. A server, if you run it yourself, that you can buy for about 300 grand will cost you millions of dollars in the cloud for the life of that server. Like 5 or 6 million. So things that run all the time are cheaper in the data center. Things that run sporadically are cheaper on the cloud. So I've got a retail website that comes along where the servers are built to deal with Black Friday through Christmas holidays in the United States. The day after Thanksgiving is Black Friday. In case you're outside the US, that's a holiday when it's a day where all the retailers go on sale and they go from red, which is loss, to black, which is profit in that time. So that is when web servers are built to handle that capacity. The rest of the year, they sit around and do nothing. They operate at very low utilization. So in the data center, you have to build for that. In the cloud, you can build for that when they're doing nothing all year long. And then as soon as you expect it, you can do a scheduled auto scaling and add the capacity you need just for that holiday and then shrink it back. That is cheaper. Or we may have an architecture, this is, say, event driven. If this happens, then this. That's typically cheaper in the cloud than the data center. So if we're going to get our cost right, we have to buy the best thing. So I remember when I was a paramedic paying through college and I was working 70 hours a week, and the only store I ever had time to walk into was the 7-Eleven across the street from the firehouse. And let me tell you, everything I bought was expensive, but I didn't have time to go anywhere else. So I was buying a bottle of water for $3 versus, the 60 cents that it would have cost at the time to go to the supermarket. But I had no choice because it was the only thing that was there. The cloud is like 7-Eleven. You're paying a lot for the convenience. The data center is like going to the store and doing it yourself. So to me, that's there. Personally, inside this company, we bought an $11,000 worth of servers and turned it into an OpenStack cloud. Running that on the public cloud was a little over $11,000 a month. We've used these servers now for 4 years for $11,000. They're the same servers that AWS charges about $1,000 a month, the i3 systems. But kind of keep that in the back of your mind. So some things are cheaper. And wouldn't you want to maximize your cost efficiency? I would. Now let's talk about performance. Mark, does the quality of service and all those other cool things in the network improve performance if we use it right?
When it comes to quality of service, and this is quite a misconception, even among just general network engineers, it only truly helps when there's congestion.
Yes.
Now we can of course reserve. That's the whole idea behind quality of service, right? We can assign certain markings to it so that we can treat traffic a certain way. Sometimes we call this unfair preferential treatment of traffic. But that's the reality, that we have to assign a certain criteria on how we want to deal with traffic in case there's some kind of contention or congestion on the network. So, and generally speaking, a very easy way to fix any of that is just throw more bandwidth at it. But of course, when we're dealing with something that's going to go over a wide area network, again, we got to keep cost in mind. Some higher bandwidth links perhaps are not going to be cost effective. So that's not going to be taken into consideration. But generally speaking, what you'll see is at least one good circuit that's being provided so that you have high bandwidth, and then usually something more of a backup. Could either be a VPN connection through IPsec, right, if we want to talk clouds, Or you can go, if you want a high availability kinetic bandwidth, then you can go with like a direct connection, where generally just means you create basically a cross connection in a colo or data center, wherever the cloud service provider is. And that way you can get your 40, 60, 100 gigs throughput even higher. But yeah, only when there's contention. That's very important.
Only when there's congestion, but the problem is there's always going to be congestion at some point. So, you're always going to push something to its limits. And if you want to get more mileage out of it by not upgrading your systems as often, you're always going to reach a contention point. So there's that. Now, Mark, if I've got all my systems if I've got a high performance system and they're in the same building, and then I've got a high persistence performance system that's 1,000 miles away that I need to access, will I get better performance for the stuff that's in my same building that's not 1,000 miles away?
Well, there is the law of distance either way. The closer it is to you, the faster it generally will be. So to give people some idea is, let's say that I have a server in Australia and I'm in the United States. Light can only travel so fast, meaning I have built-in latency or basically delay that's going to be in there, that I can't, no matter how much bandwidth I throw at it, no matter what type of infrastructure I throw at it, I can't overcome. If it's local to me, meaning the shorter distances, then having more bandwidth available, or throughput, let's go with throughput rather, because that actually is something that we can measure easier, and it's actually more real world. Then I can work on, depending on what type of wide area network connection I get, then I can work on my delay and my latency. If it's internal to me, the world is your oyster. What do you want to go with? Non-blocking switches, multiple ASICs, which are specialized chips, or your favorite, if we go with fiber optics, right? So fiber optics within our network will give us the best not bang for a buck, but will give us the best performance because we have less, interference. But the nice thing about it, of course, is that we just have more throughput available to us compared to just standard copper cabling.
Yeah. And if I want to add 4 more 100 gig links and my switch is supported, I just put the cards in the switch, the lasers in the switch, and run my cables, right? How much would 400 gig links cost from Miami to Ohio? I mean, how many tens of thousands of dollars a month are we talking about? Or even $100,000 a month?
Yeah, I mean, people be shocked. I'm not going to give numbers because they will vary based on, let's say you're in the United States, what state you're in and what type of service provider you have. But I think people will be quite shocked just how much a T1 connection, which is just 1.5 megabits per second, actually does cost when you're trying to just lease it out. It's still at least a few $100s. I've seen them still be about $1,200-1,300. So it's not necessarily that cheap, but you do get what you pay for predominantly, right? The more bandwidth we need or throughput, the more reliability that we want, basically how our packets are being delivered more often than not, we're going to pay for that because that's called a service level agreement. So the better service we want, the more guarantees we want, guess what? Put your money where your mouth is. You got to pay up for it.
Very true.
But in our data center, we can snap these cards in, we can run our cables, and it's not an expensive thing each month.
No, I mean, in the data center, it's relatively cheap, depending on what you go on. Now, it's going to be a little bit more expensive if you go, let's say, with a modular type of switch, because the line cards are going to cost a little bit more. But you can easily find some nice data center switches, fixed form factors that easily have 10, 40, even 100 gig interfaces on it. So from that perspective, it's a lot more cost effective to actually design it and implement it. But of course, you need that capital, right, to be able to buy the equipment and then be able to gain that extra performance. So it's,
or the ability to finance that equipment, one of the two. I mean,
and then write it
lease
off.
the equipment.
Very
So
true.
either way, but the point is we can't get rid of the latency because of the speed of light, no matter what we do.
Yep.
We have no control over somebody's network, so we lose the performance on their network. So in our data center, we get better. And honestly, it's better, it's faster, and it's cheaper for specific workloads. In other cases, the cloud is there. So now that we're thinking about that, now let's talk about quality and capability. Let's talk about outsourcing to a single company. So I have to tell. So I'll give you some information. If you're new to architecture, you're going to be an executive. So every business has succession planning. If I get hit by a bus tomorrow, who would run my company? And I have 2 people already that, in my head that I can see how they can do it and how I could transition them to make sure that our students are taken care of, even if I were to die. And who else would be my backup? I can tell you, most people already know who that is by the amount of architecture time and discussions he and I have. But, I'm always thinking about that. I can't give everyone the keys to the kingdom. I just can't do it. And Chris has backup plans too, because he's aware, anything could happen. I can't just give it to another company and say, here, it's all yours. And generally speaking, you can't give anything as a rule to a single person. You need multiple people with multiple sets of skills. So let's talk about what happens if you outsource everything to one person. When AWS had their outages, guess what? And they had an outage last week on the same day as Microsoft, but not at the same time. So if you were a hospital on both, you were still good to go. But if I give it all to another person and they have a problem, I'm done. We've all heard of the actors and actresses and other wealthy people that had a finance manager that managed their money and then they embezzled it and it all went away.
Yeah.
Or the manager that mismanaged their money and they went from hundreds of millions to zero. But let's talk about a more recent example. And I'll tell you what we used to do in banks. We literally would do is we'd have two separate switches in the bank. Trader one, let's say I'm trader one, would be plugged into one switch. Trader two, the guy that was next to me, would be plugged into a different switch. At one point, we were actually having half of the traders on Sun Solaris systems and the other users on Windows. And that way, if we had a Windows problem, you just go to the Sun Solaris with the old Sun Microsystem systems. And if you had a switch problem, we were good because we knew tech does fail. Tech does fail. Tech is going to fail. So we planned on what happens when the tech failed. If trader one went and traded, $50 million of the stock and it was crashing and that trader couldn't do it and he could go to trader two's desk and dump it, that could be a lot of money for a business, because especially in these trading firms. So we did that. We called it salt and pepper. You're salted on this switch, you're peppered on this switch. Yeah. And plus there was a group at the time, Salt and Pepper, that made really nice music. So that's kind of where we came from. Alonzo, I'm sure you remember that. We're the same age.
Oh, yeah.
So,
especially growing up in New York.
Yeah, exactly. So, kind of think about it from that perspective. Now, there are companies that didn't think about this. I would use two security companies and I would half of my systems on one and half on the other. Some people thought they could outsource it all to CrowdStrike. Here, you could just write to my systems. You can write up to the kernel. You have full access. We agree with you. Well, hospitals were taken down. Airlines were taken down. Half the world was taken down because they put all their eggs in a single basket. Now, this was a case, multi-cloud, multi-security vendor, multi-this, multi-that. But that's what you have to plan as an architect.
Yeah.
You have to know it's going to break. And you literally have to game the system, like with game theory. Like, what happens if this were to occur? What happens if this hacking event were to occur? What happens if this occurs? What happens if this worm occurs? And literally, you got to go test it. People bringing in IXI as a generating traffic. I've worked for companies. We spin up 2,000 virtual machines and launch an attack and see if we could do it. And of course, I've helped design cloud since like late 90s, but that's neither here nor there. I don't mean just the user end. I mean the cloud providers themselves. But, so we always plan these things because systems go down.
Yeah, just to piggyback on that briefly, Mike, I think people are under the impression that if I go with a cookie cutter template design
yeah,
in my network, that, we know about them, 3-tier, 2-tiers, there's all different types, that automatically provides us some type of resilience. And what they forget is the only way to truly achieve resilience is to plan for it, meaning you actually, as the architect, you sit down with your team, including the engineers, the ones that are actually going to be implementing the things that you ask them to do, and try to figure out how could the system fail. And you build paths around that failure. Now, you're not going to be able to catch every minute failure, but there's things that you can plan for that are going to allow you to increase the resilience of your network, which is also going to increase your reliability. And very important for us is also the availability, especially when you're talking about mission critical companies, hospitals, government entities. For many recently, it was airlines, right? That is critical for people to be able to travel. So we have to keep in mind, these things are to be planned out. They don't happen by accident.
Yeah, definitely ensuring that interoperability and everything being portable to continue that business continuity is just key. And it goes right back full circle to not investing into one particular technology, making sure you understand the total cost of ownership, the ability to understand that support, the management of it, the data transfer and so on is key. I just can't stress it enough. You can't broad brush and think that one solution for one particular enterprise is going to work apples to apples for another. It may not. So getting those right resources, getting those right qualified people, having those discussions based off of the silos, customer relationship management, enterprise resource planning, Gen AI, and so forth, to ensure that everyone is going to be able to optimize this efficiently, or you're going to be talking to the chief financial officer about FinOps and trying to mitigate all the lost money, and that's not going to be a fun conversation.
No, and it's not. So let's talk about how we make this work. Mark, have you worked on BGP, on Cisco stuff, Juniper stuff, AWS stuff, Azure stuff, Google stuff? Does it work on all clouds?
99% of the time, it does.
Yeah.
Slight variations among vendors, but let's say 99.9% of the time it works well.
Now, let's say there's two options with regards to routing. There's basically two interior gateway protocols that I've been willing to use for the last 20 years. And they are either intermediate systems to intermediate systems, or OSPF, or Open Shortest Path First. Now, Mark, let's say I wanted a network where Switch Company 1 makes the best edge device for aggregating things. Switch Company 2 has the highest performing core router. And maybe at that mid-level in between them, I need high-speed routing, and Switch Company number 3 has that. If I use OSPF internally, will it work?
Yes. But
now let's say I decided that the core switches only run this routing protocol called EIGRP that comes from Cisco. Now, without getting into crazy route redistribution and translating between routes, which I know we have the capability to do, which adds a lot of complexity and induces a lot of risk, is that going to work with Juniper and, say, Arista, a routing protocol that's proprietary to Cisco?
Generally not. So while EIGRP has a draft standard in place, it has not been widely adopted. So meaning Juniper generally won't be programming their switches for it, Arista, and so forth. So it would not necessarily be the best if you're looking for interoperability.
Right. But if we went with an open standard like OSPF or IS-IIS, we'd have no problems, right?
Definitely, yeah. Open standards.
Now we're in the cloud.
Supports it.
Any platform supports it. Now, how do we make multi-cloud work? The first thing to think about is if it's cloud provider proprietary, it's no longer usable. Don't waste your time with it. So what does that mean? It means Amazon has this beautiful and is honestly elegant Elastic Container Service for container orchestration. You can't use it because what's going to happen? What's going to orchestrate your containers in Azure and Google at the same time? Throw it away while we're at it. If we use the cloud provider's Elastic Kubernetes Service, for example, and the AWS cloud goes down, what's going to be the control plane in Azure and Google? Nothing. But if we go to IBM and they have OpenShift, which is a managed Kubernetes service, and we put that in AWS, Azure, and Google, guess what? One of the cloud providers goes down. We don't care. Now, if AWS, for example, Route 53 is my company's DNS, and whoops, AWS goes down, is my website in Azure and Google going to work? No. But if I don't use AWS's DNS, and if I call F5 and I put DNS servers and all cloud providers running on a virtual machine, one of the Azure goes down, no big deal. Google and AWS in my data center are up. It doesn't matter. If I don't use Amazon Aurora and I replace it with an Oracle database or another relational database that works in all clouds, like Oracle or Microsoft SQL or MySQL. If I get rid of DynamoDB, Azure Cosmos, Google Cloud Bigtable at the same time, and I swap it out with Apache Cassandra or MongoDB, it all runs in the better clouds. Now, here's the best news. The cloud providers like Walmart, and I have a lot of respect for Walmart. They run an incredible store with some of the best supply chains in the world. They have everything and they can deliver it at a good price. They really can. And if you got to return something, my wife tells me they're easy on returns because she buys 10 times more than she needs, and then she returns it and then she goes back and buys something else from every store. She says they're good on returns. So I don't know. I don't go shopping that much. I've got a bad foot, but kind of think about that. But if I use these proprietary things, I'm stuck. I'm really stuck. So get rid of it. And who do you think has more time to make a better firewall? Palo Alto with 100% of its people focused on security, for example? Or AWS, who's virtualizing clouds and they're trying to get in healthcare. They're now trying to be your pharmacist or your retailer. Here's a little cloud this, here's a little cloud that. Well, there's lots of good reasons why Palo Alto will make a next generation firewall that will outperform AWS WAF or Azure's firewall or Google's firewall. It has a lot more enhanced capabilities because that's their whole business. So by getting rid of these cloud provider proprietary things anyway, you choose to get the bigger, more robust standard. And quite frankly, OSPF is a more robust standard than EIGRP because it has to work with everybody. BGP is a more robust standard because it has to work everywhere. So don't lock yourself into this proprietary stuff. And then multi-cloud's easy. Now let's talk about the things that can take a cloud down. Well, here's the thing which most people that come from an application perspective don't know, where the networking people do know. The cloud is nothing more than a network. I mean, the first clouds like ISDN and Frame Relay were networks. Then we got into the BGP cloud. If you wanted to read about it, it's RFC 2547. My team worked on that for years. Then my team worked with Luca Martini and Juniper, and they came up with those Martini tunnels or those layer 2 pipes over MPLS. Then my team worked with some of the VPLS standards to try and get that to happen. And then a couple of years later, after we built all that, here you go. Now we're going to stick some servers in the same cloud. Same kind of thing. So think about it that way. It's all the same. But, the network goes. I promise you, your whole cloud goes down. Mark, would you agree with the cloud provider's network goes down? Or what happens, Mark, if the cloud provider is multiple regions and they still get a bad routing? Somebody does something ridiculous in BGP. Someone redistributes a route that's a black hole. Can that take the whole cloud down?
Yeah, we have proof of that. It has happened in the past. As a matter of fact, you could say probably one of the, and I don't know if I guess I would put it number one, is hardware failure is basically what takes most networks down. And then the second one would be actually a configuration mistake. And when I mean configuration mistakes, this doesn't have to be just a person doing it. It could also be through an automation system. So if you're pushing a configuration through an automation system, could be Terraform, could be whatever, Ansible, you can still cause issues. That's really the problem when the two main problems, I would say. And then of course you got attack vectors, but I would say that definitely is an issue. Yeah. And one of the biggest problems I would tell everybody is we're using BGP anyway between two different organizations, right? So that's the advantage of using BGP. We don't use it necessarily internally unless we need to have the attributes go through. Yeah. But it's very easy, unless there is some kind of mechanism in place, which there is today, but to basically claim that you're somebody that you're not and kind of black hole the traffic that way, right? You don't have to necessarily take the whole network down. You just need to redirect the traffic. So just a simple policy change that is not well thought out of, the way it's then being actually advertised to other upstream ISPs can cause major issues when it comes to any type of network, but especially cloud providers.
Yeah. So if we have a major network failure, like the BGP cloud was taken down by a major network failure. Yeah. Alonzo, you're back. Do you remember when Facebook was down for basically a whole day because someone made a BGP error?
Oh, definitely. That has gone down in technology and enterprise infamy about how long it went down and more importantly, how much it cost.
Didn't I think Cloudflare, I could be wrong, had a pretty big outage a couple of years ago, and I think they had a major BGP error as well.
Yes, they did.
The point is, that's just a routing issue can take it down.
Yeah.
No. Generally speaking, anytime we have anything, we typically have a control plane and we have the forwarding plane or the data plane. With Kubernetes, that's our control plane where the virtual machines where the containers sit. That's the data plane. Now, the problem is the cloud provider has to have a single control plane because you have to be able to go to your management console and be able to, or CLI and be able to get stuff to work in other parts of the world. If the control plane goes down, you lose the entire cloud. So the two answers that Mark and I gave you, you could be in all 10 different availability zones in 3 different regions and you're still down because the network went down or the control plane went down. Now imagine the cloud provider gets hit with a big security event like a DDoS attack. What happens if a massive security attack happens, Alonzo? Is that cloud still going to be up?
It's going to be severely compromised, to say the least. Mike, let's talk about what happened last year in Las Vegas with that type of lack of security layer that caused that issue. in Vegas with the casinos. And I think
I
it
can't
had
remember
something
what
to do with
happened there.
multi-factor authentication. I think it was a little bit of some social engineering. It had, I think they did not have the preparations in place for their employees to understand how to mitigate against these attacks. And, you know, Mark, check me if I'm wrong, but I bet, I think it had something to do with a phone call to security. Someone acted as a executive looking to push some payroll at the last minute because their security protocols were down. They ended up getting a hold of that information, and the rest is history.
Yeah, the oldest trick in the
so-
book, right? Pretend payroll is due and you got to push it out, and everybody's frantic as soon as you mention that the CEO is calling, right? But what you mentioned, Alonzo, is, again, failures happen, but what we really notice there is the skill gap that you really see. Now, it does increase, right? That I want to point this out. When you're talking about multi-cloud, you're increasing complexity. You're also going to increase skill gap because you do need people to be able to manage that. So what happens a lot of times, especially with users that, let's say, their job is accounting. They don't know tech. They just need to make sure that the computer works. They can get to whatever services they need to get to. That telephone better be working and the emails be working, right? So they really don't understand that the huff and the fluff that's being made about, hey, make sure that when somebody calls you, that you don't simply give the information away, but rather maybe give them a call back, email them, get that confirmation, maybe check with a second person just to make sure, right? So definitely training is necessary to also help the average users, which we don't expect to be architects, right? Their job is different, just like our job is going to be different. That's what we're being paid for. They're being paid for something else, but they do need to be trained too to overcome some of these potential security risks.
Yeah, absolutely. But the point is, a security event, a control plane failure, or a network failure can and will take down a single cloud. And that's just one of the reasons we need to have more. Because when you start looking at all the things that can go wrong and you start analyzing them, which you have to do as an architect, you start seeing these single points of failures light up. So here's the secret on how to understand this and make it simple. Learn the tech. And what I mean by this is, so when I was younger, I had a Nissan, and then I had a Honda, and I had another Honda. I love my Honda. It was really awesome. And then I had a dream where I was in a car accident, so I bought a Volvo. And I loved that Volvo. I kept it for a long time, and then my back was really bad, and I sat in every car seat that didn't hurt. Tried to find one that didn't hurt. It was a Mercedes SUV that didn't hurt, so I bought a Mercedes. I think my Toyota or Honda was a better car, but the Mercedes had the best seats, so I bought it. You know what I didn't have to do when I got in each car? I didn't have to get retrained again. Now, granted, I knew that the Honda thing was this thing over here, and the Mercedes thing was over here. And when I tried initially to turn on the windshield wipers, I pushed the button on the side, and it accidentally tried to put it in park, but I was moving, so it didn't let me do it, thankfully. The point is, I knew how to drive. And if you know what a virtual machine is, it doesn't matter which cloud it is. If you know what a container is, it doesn't matter which cloud you're in. If you understand Kubernetes, it doesn't matter. If you know what a database is and how a relational database works and how to scale a relational database, it doesn't matter. If you're familiar with NoSQL databases and you use an industry standard one, it doesn't matter. It's pretty darn simple. It's the same thing. If you say, okay, instead of Amazon Kinesis, we use Kafka. Instead of Amazon SQS, you use Kafka. It's just a queue. So that's the key to remember. It's all the same stuff. It just has a different name. So go out there and learn to drive. Learn the cloud. I think we have one question which we'll answer, and then we're going to be available right after this in about 5 minutes. My team will take a stop, and then Mark and I will come back for career questions and answers because we want to help you. But I do want to get that question from AB Fimbo. Great discussion. Will the network architect have to build bespoke multi-routing platforms based on BGP, ISPF, OSPF, or should they seek to work with SD-WAN vendors? You're going to need both. But I want you to understand this. If we use a single SD-WAN vendor, like Aviatrix, and Aviatrix is awesome. Verizon Networks is another good platform. But if we use just one of them, they become our single point of failure. So we can't just use any network as a service provider, or we'll be now inducing new single planes of failure and new control plane that's managed by somebody else. The key is we need to know both. So at bare minimum, we need to know BGP. And the reality is, without knowing interior gateway protocols like OSPF, your value will be very limited and you won't be able to do any networking architect work. So no, you're going to need to know both. We can't, as architects and network architects, and this is the key, we can't love any piece of technology. I think Aviatrix is a great company. I speak to their leadership all the time. I love working with them. They're awesome. And I really respect them. They're great. But everything breaks, no matter how great it is. So if you put all your eggs in one basket and you deal with the best, when the best goes down, you've got a problem. But maybe you deal with the number one player and the number two player. And then when either the number two player goes down, you're fine with number one. Number one player goes down, you've got number two. And we can't just map any piece of technology to any solution. We need to know what we're doing. We're going to build a private cloud. That's going to happen over interior gateway protocols such as OSPF. Now we want to optimize our WAN. Maybe we use SD-WAN. Maybe we just use standard private lines based upon the performance we need. But the business requirements will drive these tech requirements, and we need to analyze the business needs before we go down a tech path in all cases. But really, really great question. Lonzo, you want to add anything as we close?
Absolutely. I think it's always critical for everyone to understand that when it comes to multi-cloud architecture, you really have to understand its complexity. You have to understand the nuances that it takes to keep everything up and running. It's more than just a cloud. It is an entire technological presence that an organization uses to be effective in both internal and, for its stakeholders as well as for its customers. So take the time, do the due diligence, understand these compartments as well as architectural frameworks like the TOGAF to help you be more efficient in how you deliver value for the organization.
And to piggyback a little bit on what Alonso said too, we tend to put blinders on at times when we discuss certain technologies, right? Because our focus is the technology. But even with something such as like a strategy like multi-cloud, there has to be a purpose for it. Just because 98% of businesses potentially use it, I know it's 90 and plus, quite close to 98, doesn't mean that your organization should go multi-cloud.
Right.
So that's one thing, right? There's definitely also a cost involved. We spoke about many of the advantages of multi-cloud, but one disadvantage, if not managed correctly, could be cost. I know Alonso has brought it up many times also to our students that if you don't consider the finances of it, simply sitting there and thinking what technology is cool and trying to implement it, it's not going to cut it. You can't do it. But go ahead.
We're so there, but putting 50% of my systems in AWS and 50% of my systems in Azure doesn't cost more than putting 100% in either one if I split it out. So yeah, now there is going to be a cost of greater people because now we're going to need people that actually know something. Truth be told, I'm not going to hire anybody that doesn't know anything anyway. So it doesn't matter. I hire great people instead of people that might almost be able to do the job. And I need 10 people that almost need to do the job. I'd rather pay one person that can do the job and do it really well, even if I have to pay them more, because they'll do more than the other 10 people that don't really know what they're doing. And they'll make less errors. So I'd rather have better people.
To piggyback on what you just said, you have to ask yourself, and I hate to put it this way for everybody, but money does matter. Money is actually one of the biggest restrictions that you have because it's just a finite that usually you have available. So you really have to ask yourself is what is that failure going to cost that organization?
Yes,
and then you try to figure out what solutions you can put in place. Because if let's say it's cost you $1 million to design, implement a solution based on high availability, let's just say something like that, $1 million. And you said, hey, that's fine because we figured out if we're down for 2-3 hours, it's going to cost us $5 million, right?
Yes.
So now you know that your risk to reward, your reward is a lot better and your return on investment than if you just said, you know what, I don't want to spend $1 million. Well, guess what? You just saved $4 million. So cost matters. Being able to talk to the various department heads, trying to figure out what this is, that is also a very important aspect of you.
Yeah.
Understanding what a failure will cost you. And in certain settings, it costs lives. And no matter what anyone tells you, I don't believe it. You can't put a price on somebody's life, regardless of what some people claim.
And if you look at a company like Amazon, they lose roughly $1 million per second of not being in business. Think about that, because that's what we're seeing with some of these businesses, $1 million a second. Now, what happens if you're down for 4 hours? That can be catastrophic and irreparable to some businesses, where other businesses, it really doesn't matter. So these are the kind of things we need to think of. What lives are at stake? What happens when the business is down? What are the needs? So there we should go. So we're going to end on these two things. If you want to learn how to be a multi-cloud architect and get your first architect job, join us tomorrow, the completely free webinar. We have a free webinar tomorrow. We'll go over the architect role, which is always fun to talk about. We can answer any questions you may have. And I always love answering questions, and my team loves helping people. So we have that tomorrow. We also have a tremendous number of free resources in the description of this video, including how to become a cloud architect, how to become an AI architect, how to win the interview. So many things, and they're all free. So go download them. In any case, thank you all for being here today. And we will hopefully see a lot of you for the question and answer session in the next hour.
Thanks for joining us, everyone.
Thank you for joining us.